Assalamualaikum everyone. This is going to be your Math A-levels class, and this is just a demo session. So we'll be doing a very small part of your E1, that is your pure one mathematics paper, and we'll be studying quadratics today. So what really are quadratics? Before going to that, we'll first study a very basic concept of linear equations. What are linear equations? Linear equations are the equations in terms of y is equal to mx plus c, in which we've got y and x as being the coordinates of the y and x axis, and m being the gradient, while c being the y-intercept, मतलब where the equation cuts the y-axis from. So moving towards our quadratic equation, is in the form of y is equals to ax squared plus bx plus c. What really is a quadratic equation? A quadratic equation is an equation that has that has one term that is in x squared. Also, it has this quadratic equation has three constants that are a, b, and c. Now, quadratic equations can be written in another form that is called the completed square form. We write it as y is equals to x plus h whole square plus k. Here again, we've got y and x being the coordinates of the x and y axis, whereas h and k here are the. Now, moving towards our first topic, that is how to convert a quadratic equation to the completed square form. So there are two very basic steps about how do we move towards a completed square form from a quadratic equation. So what do? We have the coefficient of x, matlab, whatever we have with x, we divide it by 2 and then we square it. What do? We have the coefficient of x and then we square it. And the second step is we have to add and then subtract it from the equation. So now why do we really add and subtract it from the equation? We just add and subtract it from the equation to reach the way how our completed square form is represented. But why do we add and then subtract it is because that our equation becomes equal again. For example, किसी भी equation में से we add 2 and then we subtract 2. So since the value becomes 0 again, it is of no value at all. So this is how we go from quadratic to square form term. So now we'll do one very basic example to clarify this process, this concept. We'll take an equation that is, for example, y is equals to x squared plus 10x plus 32. So what is our first step? We have to have the coefficient of x and then we have to square it. So y is equals to, no, actually, first of all, we add brackets to the x terms and we make the constant alag. So what do? We write the first two terms as they are, and then we have the coefficient of x and then square it. And then we write it plus 32, and then we subtract half the coefficient of x and then square it. So this was our first step, and this was our second step. Now moving forward with it, we simplify it as we take these two terms and make a whole term. X plus 10 by 2 gives us 5, and we take the square common, and we just reject this term, we just take it out of the equation, and then we simplify the constants. That becomes plus 32 minus 5 squared. Simplifying the equation further, we get y is equals to x plus 5 whole square. Plus 32 minus 25 gives us plus 7. So this is in the form of the completed square form. Now this was a very, very simple example. We'll move towards another example that is a bit complicated. So we can take it as y is equals to 2x squared plus 10x plus 7. What do we really have to do with this? Now we need x squared key term alone, so we take 2 outside and we separate the coefficient. Then we apply our first rule, which is halving the coefficient of x and then squaring it and then subtracting it. But what is the difference here? Now, since this 5 by 2 is being multiplied by 2 here, we'll multiply this 5 by 2 by a 2 as well. So simplifying it further, we get y is equals to 2. We cancel this out, we get x plus 5 by 2 whole square. And then we simplify this and we get plus 7 minus 25 by 2. So the final equation now becomes y is equals to 2x plus 5 by 2 whole square minus 11 by 2. This is now in the form of completed square method. So I hope you understood how to convert an equation, a quadratic equation, from a very simple form to the completed square form. Now we'll move forward to our next topic, that is how do we solve quadratic equations. Now we've got two methods about how do we solve the quadratic equations. The first one being the midterm breaking that we've done before as well in our O levels. So the midterm breaking method. Now I guess I'll just show you by an example. Y is equals to x squared minus 6x plus 8. So what do? We take the first coefficient and we take the last coefficient and we make factors of it. We get an 8, we make factors. 8 factors are 1 into 8, it's 2 into 4, and that's it. So how do we get a minus 6, which is the middle term, by 2 and 4? Minus 6 from 2 and 4. So minus 2 and minus 4 give us minus 6. So what do we really have to do? Y is equals to, what we'll do, we'll break down the middle term because it's named as midterm breaking. So we'll break down the middle term. Our middle term was minus 6 and we'll break it down into minus 4x minus 2x plus 8. We'll make factors. Oh, sorry. X will be common. X minus 4 minus 2, x minus 4. We'll make two brackets out of it. X minus 4 and x minus 2. These brackets are being made by x minus 4 and then this x minus 2. So what we get is x1 as 4 and x2 as 2. So this was the first method of how we solve quadratic equations. Moving towards the second method, that is the quadratic formula. So what is the quadratic formula? The quadratic formula is x is equals to minus b plus minus under root b square minus 4ac divided by 2a. Now you have to learn this quadratic formula because there is no other way out. I think it's given in the formula sheet, but I'm not very sure about that, but learning this would be better. Now, this part of the quadratic formula is called the discriminant, and the quadratic formula is x is equals to minus b plus minus under root b square minus 4ac divided by 2a. We'll do an example. We'll take the same equation that we took in the midterm breaking, which was y is equals to x squared minus 6x plus 8. Now, what are a, b, and c in it? We have a as 1, we have b as minus 6, and we have c we have a as 1, we have b as minus 6, and we have c as 8. So putting this into the quadratic formula, we get y is equals to minus b, so minus 6 becomes plus 6, plus minus under root b squared becomes 36, minus 4 into a becomes 1, and c becomes 8. Divided by 2 into a is 1. So we get y is equals to 6 plus minus under root 36 minus 32 divided by 2. So solving this further, we get y is equals to 6 plus minus under root 4 divided by 2. Sorry, this is x. So now taking the positive one first, x1 becomes 6 plus under root 4 is 2 divided by 2. So 6 plus 2, 8, 8 divided by 2, we get 4. And then x2 becomes 6 minus under root 4 is 2 divided by 2. 6 minus 2 is 4. 4 divided by 2 is 2. So we get the same answers again. Now moving towards the next concept, it is the discriminant. What is the discriminant? The discriminant was also the part of our quadratic equation for the quadratic formula. So the discriminant is b square minus 4ac. What is the purpose of the discriminant? The discriminant tells us the nature of the roots. It's only used to determine the nature of the roots. Now we've got a lot of uh, you can say rules on how a discriminant is used. So the first thing is, what if the discriminant, that is b square minus 4ac, is greater than 0? If this gives us a value that is greater than 0, that represents that it has two roots, two distinct roots. Now, two distinct roots means it has x1 and x2 that have two different values. Now, if the same discriminant is less than 0, this gives a value that is less than 0, so we've got no real roots. And no real roots in math means that we've got roots that are in terms of iota. So that's complex numbers, and we don't really consider them as real numbers. Now, the third is, what if the discriminant is equal to 0? What if we get a complete 0 with it? So if we get 0, it represents either repeated roots or it represents just one root, which means that our x1 is equals to x2. We just get one root. And then we've got a fourth one where we say that b square minus 4ac gives us a perfect square number. Now, a perfect square number is a 4, which is a square of 2, 2 square 4, 3 square 9, 4 square 16, and so on. So if we get a perfect square, what we get in the roots is we get same roots, but they've got different signs, which means that if we've got our minus 6, for example, the answer becomes minus under root 4. So what do we get? We get plus 2 and we get minus 2. So this is it for the demo lesson, and I hope I was understandable, and I'm hoping to see a lot of you in our classes that we start. Thank you so much.